to do one example of this, angles and sides of triangles. We did kind of one on Friday, but never really finished it. Once that's done, I'm going to look at a big chunk of work. A big chunk of work called work done. So we're actually going to use dot products to calculate the amount of work done in moving things around. And then the last one is a little tidy up thing, which we're going to deal with calculations involving a dot product, the algebra of them at least. So this one, we're just going to do it all the way through. Suppose I have a point P, coordinates 1, 3, another one 2, 5, and the third one 3, -5. And I could plot those guys, but I'm not going to bother. We want to do it purely mathematically. So although I'm not plotting them, can we pretend that that's just a visualization of what a triangle will look like? And we are going to find all 3 angles and all 3 sides, at least enough to be able to do it. Just like last time, I'm going to start with angle at P, and I'm going to call that angle theta. I'm going to find the vector joining P to Q. And 2 take away 1 gets you 1, and 5 take away 3 gets you 2. So the vector from P to Q would be 1 along and 2 up. So imagine that's 1 along and 2 up. If we then do P to R, it would be 3 take away 1, which is 2. And -5 take away 3, which is -8. So can you imagine going from here to here would be 2 along and 8 down. You can say that's not to scale. Now, once you know these 2 vectors, and notice that they're both leaving from P, we can use dot product formula to get this angle theta. And indirectly, we're also be able to get these 2 lengths. So the length of this vector is the square root of 1 squared plus 2 squared, which is the square root of 5. The magnitude, so another name for the length of the second vector, is that guy squared plus this guy squared. 64 plus 4 is the square root of 68. If we do the dot product of PQ and PR, we will get 1 times 2 plus 2 times -8, which is 2 take away 16, which is -14. So that's us got all the pieces. We can now calculate the cosine of theta. It's the dot product divided by the 2 magnitudes. So the cosine of the angle between them is going to be -14 square root of 5 and square root of 68. And so to get theta, we just take the inverse cosine of this ugly fraction. So I'll make sure my calculator is in the right mode. And if you notice, it's in the wrong mode. It should be in degrees. Now I can do inverse cosine. -14 divided by square root of 5 times the square root of 68. And I get the answer 100, and we're just going to make this to the nearest whole number. So that angle there is 139 degrees. When you use the dot product to find the angle between vectors, the angle you get is the one you use, right? You don't need to worry about, when you do the inverse tan, for instance, you get a number, but it's not really the one you want. That's not the case here. The cosine gives you the exact value every time. And on this triangle, I'm going to put some of the things that we've indirectly found. I now know that this guy is the square root of 5, and I know that this guy is the square root of 68, and I know this angle in here is 139 degrees. So far, so good. So what am I left with? One more side and two more angles. At this point, things can take a different route. If I wanted to, couldn't I just stay on dot product, right? Maybe focus on Q or R, whichever one I felt like. And then I could do QP and QR and do a similar question, right? And that would work. But someone on Friday suggested a very reasonable thing to do is couldn't we also find this side here by using which rule? Not anything here, but what rule from way back in week 2 or 3, I can't remember when.
The cosine law.
The cosine law, agreed? So let's do it that way. This is little p, this is little q, and this is little r. Now I know we're used to A, B's, and C's, but can't you use any 3 letters of the alphabet and it doesn't really matter. So I am looking for little p. So it's going to begin with little p, make it more like a little p squared. Can anyone tell me the cosine rule formula for finding little p using the r's and the s's and the r's and the q's and whatever? Yeah, frantically looking up notes here. It's much better if you have it in your head, but anyway, I'll take what I've got. What you got here? I'm putting a line there. I don't know why I put that line in there. Don't need a line.
Is it r squared plus q squared minus 2rq cosine p?
Excellent memory, Grace. Did you do it with memory?
No, I looked at my notes.
But that's okay, because won't you have your notes in front of you when you're doing your final? So it's not anything bad. If you don't have good notes, can you see how much trouble you're going to have in a final exam where you have to spend 5 minutes for every question just finding the right formula because you know you've written it somewhere, but you haven't written it anywhere else. So think about putting together good formula notes, right? Little cards with just the sine rule in it, the cosine rule in it, this dot product rule, all those kind of things. So they're all in one little pile, and if you want a formula, you only need to look through a little pile, not 20 pages of notes instead. In this case then, p squared is going to be square root of 5 squared plus square root of 68 squared. Take away 2 times square root of 5 square root of 68 and the cosine of 139 degrees. Well, I can do that as 5, and that's 68, and then I guess I could do this in one horrible go. So -2 times the square root of 5 times the square root of 68 times the cosine of 139. And the answer I'm getting here is, I wish I hadn't put my negative, but that's fine. It ends up being positive 27.8. So p squared is 27.8. Add 68, add 5. So square root of 100.8. So the answer is going to be 10 point something. Let's find out what it is. Square root of 100.8 is 10 point. Well, to one decimal place, isn't it? Just 10.0. Because 0.3 rounds off to 10.0. So I now have the guy that goes here. I'll just call him 10. Okay, we have 2 more guys to go for. right? I need to find angle Q. I need to find angle R. Couldn't I do it like this again if I wanted to, but I'm not going to? What formula could you use to find angle Q?
You could use sine or cosine laws.
You could. Let's just do the sine one. I just want to do a mix and match. So in this question here, I can then move on, and it's going to be sine P over little p, sine Q over little q, sine R over little r. And what do I know? I know little r, I know little p, I know little q, and I know that guy. And since I've decided I want to find q, do you see, that means I'm using those two ratios. So the sine of P becomes the sine of 139 degrees over little p, which is 10. The sine of Q, I don't know who you are, over little q, which is the square root of 68. And then if I do a cross multiply, 10 times the sine of Q will be the square root of 68 times the sine of 139 degrees. What will I do to both sides to find the sine of Q?
Divide by 10.
Okay. I'm going to figure out what that is a decimal. It's getting too ugly to keep together. So that guy times the sine of 139 all divided by 10, and that's 0.541. Okay, what do we now do to find the size of angle Q? What do I do? Okay, and the inverse sine of that guy, inverse sine of the answer is about, well, I'm doing it to whole numbers, so that's going to be 33 degrees, or the other 147 degrees. Remember, when you do a sine rule and you're finding a missing angle, there is a possibility that there might be two answers. Now, that one is definitely going to happen. Anything, the small one always happens. Why is that one in this question not going to happen?
Is
the
it
first
because-
one. Sorry.
Oh,
No, River? Who wants to go first?
is it because 147 and 139 add up to more than 180?
That's the reason. And so that's the only one that works. And to find the last one, I could make a meal of it. Couldn't I do another one of these? But wouldn't it be easier just to take the two angles that you know and take it away from 180? And that angle in there would be 8 degrees. Are we comfortable with how you find all the sides and angles? We change tack for a little minute. Your final is coming up, as you know, next week. There are going to be 10 multiple choice and 10 section 2 questions. 10 section 2 questions are these guys, right? Where you have to do a lot of work. If you were doing a question like this, right, from here, and tell me all the sides and angles, since I wouldn't in this question give you any real, you must do it this way. Couldn't you have done all the sides and angles with nothing but dot product method, right? This method here. Couldn't you have done it the way we did it with a cosine rule and some signals, and that would have worked. You could have done it with a dot product to start and then a cosine rule and a cosine rule again. All of those are correct, but I need to see the working. So if you don't show me working, I'm just going to assume that somehow or other you've got a really clever calculator that I don't know about, and you're just writing down guesses or whatever. You must get into the habit of writing down how you got the answer when it's a final exam.
20 questions for the final?
Yeah, but the section 2 questions in particular are going to be good uns, for want of a better word. I would consider this question a good one. You know, it took us about 20 minutes to do. Well, I had a lot of talking going on, but that would be a good example of it. So yeah, 20 questions. The multiple choice questions, you know, if they take you more than a few minutes, 3 minutes, you're doing them wrong. So just guess C and move on. There'll be 10 of those. And we'll talk a lot more about the final as things go. So I'm calling that one good.
So can we go back to that question real quick?
Sure.
To get that side length of 10, right? Could you do the dot product for that too, correct? Sorry, not the dot product.
Find the vector QR and then it's that's how you could get it. Yeah, you could do it that way. So QR would be 1, 10, and 1, 10 would get you the square root of 101, which is pretty much that, you know, rounding off, and that would have got you 10.0.
So how is that? Oh, just because, gotcha, I see now.
There's a phrase, I think, that goes along the lines of there's more than one way to skin a cat. You ever heard that phrase? So there can be more than one way to get an answer in tricks. And if you've never heard of that phrase, what are you doing? Bailey, will you leave that pig alone?
Like someone's throwing up or trying to.
No, he's not. What he's got here is this. Good. I think they deliberately do this to distract me because they know how easy it is that I get distracted. Are there any more questions before we do the work done questions? Are we good with that? Okay. So we're moving on now to essentially find the work done using a force vector F from some point P to some point Q. So imagine P is here at the bottom of a hill and Q is here at the top of the hill, right? And let's suppose P is the origin and Q is the point 5,7, just for argument's sake. And you have got an object here and you're pulling it at some weird angle, and the vector that you're pulling it is at 1, 2, right? Then the work done in taking this block and pulling it all the way up to the top, right, we call that the work done. And the work done is a number, a scalar, and you find it by just taking the dot product of the force with the vector PQ. So if you know P, you know Q, you can find the vector PQ, and you know F, the dot product of those gives you the work done. So in this question, we're going to use that formula, which is really very simple, right? It's just a dot product. So in the question, I've got the first thing I would do would be find PQ. So what would that be? 5 take away nothing, and 7 take away nothing. Can you see it's simply just 5 and 7? And so the work done would be the dot product 1, 2 with moving it from 5 along 7 up. And that would be 1 times 5 plus 2 times 7. And that's 5 plus 14. And that is 19. And, oh, the units, sometimes the units are foot-pounds. Sometimes the units are Newton meters, right? Whatever they happen to be. You don't need to worry about the units because they always put them beside the box that you're meant to put the number. So when you do your homework, you just stick in 19 and it will say foot-pounds or whatever the units are. So if you're not into physics, you don't need to worry about what the weird units are called. All you need to do is calculate the numerical value of the work done. Are we so far so good? Just a dot product. So let's show you some of the different ways in which that same question can be given to you. Here is question 17. The force vector, right, is 4i take away 5j. And you're going to move this object in the x-axis, right, in the x-axis, 9 feet. And you've defined the work done. So I like to use that notation. So there's the force. And the second vector, which is basically the movement one, I'm going to call it D. And in this case, if you're moving in the positive x, 9, won't that just be simply 9, 0? Right, if you're only moving it, so can you imagine what's happening? Here is my block. He's pulling it in that direction, and it's starting here and it's finishing here, and that is 9 feet of movement. So from there to there, would you agree that's 9 along and none up? So the dot product will give me the work done. So it's the force times the distance. And the force is 4 to -5 vector, and the distance vector is that one. And that's 4 times 9 plus nothing. And so the answer would be 36, whatever the units happen to be. Any questions about that version of 17? Here is 18. 18, the force vector is -4i plus 20j, and we're moving it from P with coordinates 0, 10 to position Q with coordinates 5, 30. I would turn this guy into -420. And the vector PQ is my distance vector. Right, to do PQ, you go this. I'll show you the formula again. I've been doing 1 takeaway 2 maybe far too many times. So if you want P to Q, it's second takeaway first, second takeaway the first. So it would be 5 takeaway 0 and 30 takeaway 10. And that would get me 5, 20. So that guy, right, is our direction vector. So, oops, it's not a vector. The work done is the dot product of those two. So it's -40, 20, dot product with 5, 20. And that's -40 times 5 plus 20 times 20, which is -200 plus 400. So the work done here would be 200 units.
How did
How did you get 40 times negative
Yeah.
40 times 5? It's negative 4.
Oh, is it -4? Where the heck did the 40 come from? I don't know. I don't know. Let's figure it out. That's a fact. I don't. Let's see. Yeah, fixed it. Fixed it. We're good now. Right method, wrong number. Yep. 19's similar. 20 is similar. Let's look at 21 now. They even, well, let me show you what the picture looks like. What number is this? Oh, come on. Where's my window going? Right, this is question 21. Stop doing that. It keeps moving my window around. So a lawnmower is pushed a distance of 150 feet along a horizontal path by a constant force of 55 pounds. The handle of the lawnmower is held at an angle of 30 degrees. Find the horizontal, from the horizontal, I should say. Find the work done. So if you're into physics and that kind of stuff, then this might be quite interesting to you. So essentially what we have got here is some ground, and we have a distance that it's going to travel of 150 feet. Though you can't see this, I'm writing it down, you'll see it in a minute. And we have a vector force I'm calling F. And I know the angle of that vector is 30 degrees. And I know that the magnitude of that force F is 55 pounds. So let me show you what I've written down from that picture. We're going to go from here to here, right? Right. Going this way, right? Now, I know it's going left instead of right, but would it be okay for me to just say that you're moving it along 150 feet? Is it okay to call the distance vector 150 feet 0, right? The reason why I want to do that is I want to make sure that the answer is positive when I'm finished. Now, the problem is I don't have yet the x and y component of my vector F. I know it makes an angle of 30 degrees, and I know the magnitude of it is 55 because he's pushing with 55 pounds of force. But don't I need to know these as numbers, and then I can do the dot product? So we have to figure out how to find the x component, and then how to find the y component. And then we can get the answer. Can anybody remember finding the x and y component of a vector whose magnitude is 55 and makes an angle of 30 degrees? Can you remember the formula for finding the x and y component in those situations?
It's the magnitude times the cosine, and then the magnitude times the sine.
Are we comfortable with that? You remember those guys? So in this case, it's going to be 55 times the cosine of 30 degrees. And here it's going to be 55 times the sine of 30 degrees. I'm not going to use my unit circles, even although those guys would work, because we're going to have to, combine things together anyway. So I strongly suspect, well, I should check that. Yeah, round off your answer to the nearest whole number, right? So they're telling me, look, don't worry about it, round it off. So that's fine. So 55 multiplied by the cosine of 30 degrees gets me 47.63, and 55 times the sine of 30 degrees, that gives me 27.5. So I now know what f is. It's 47.63, 27.5. So the work done is the dot product of the force vector with the distance vector. And the force vector is 47.63 by 27.5. And we are moving it 150 feet in the x direction, which essentially means 47.63 times 150 plus, well, isn't it just going to be plus nothing? So 47.63 times 150, I get 7144.5, which I'm a little bit worried about. So I'm going to check their answer. This is question 21, I believe. And they called it 7145. So I'm happy, right? I know this question said to the nearest whole number, but see these guys here? Don't do those to the nearest whole number. Do all the intermediary calculations to at least 1 or 2 decimal places, and only the final answer gets rounded off. And the reason why you can do that is if you did the rounding off up here, let's pretend just for a minute I called that 48. I would have had 48 times 150, and I would have came up with the answer 7,200. You see, I'm quite a long way away from that answer. And WebAssign would say you're wrong, even although 90% of what you did was exactly correct. Wasn't it just rounding off too early? So in general, any question that says round off to 2 decimal places or to the nearest whole number, whatever it is, do all the other calculations that lead up to it to more accuracy than that, right? So if they want the answer to 1 decimal place, do everything else to 3 to be safe. And that'll save you coming up with a problem that your answer doesn't agree with theirs. Any questions about the lawnmower story before we move on? Are we good? Okay. Let's do one last one of that type of work done question. Okay. I'll just draw this one. It'll save me going back and forward anyway. This is a version of question 22. We've got the ground. We've got a guy. We've got an angle here of 12 degrees. A car drives 400 feet along a road that is inclined at 12 degrees to the horizontal, as shown in this figure. The car weighs 2,500 pounds, thus it acts as gravity. So here's my little car. Can you tell why I was horrible at art class? Right, that's a little car. You've got gravity coming down the way, and that is a negative number. Evidently, gravity going down the way makes sense. It is negative. Find the work done in overcoming the gravity. And the car weighs, what does it weigh? 2,500 pounds. So if you imagine the force vector being this way, the magnitude of this force then is £2,500. Right. So what do we know here? Well, let's find the vector f. It's going to have an x component. It's going to have a y component. And the x component is going to be the magnitude of the force times the cosine of the angle. So the magnitude of the force is 2,500 times a cosine 12 degrees. The y component is the magnitude times the sine of theta, which is 2,500 times sine of 12 degrees. Let's me get the numbers set up here. This fella here is, I know what this fella here is, let's find out. 2,500 times the cosine of 12 degrees. So 2,445. What accuracy did I want there? Oh, got to 3 decimal places. Okay, 369. This fella here then, 2,500 times the sine of 12 degrees is 519,779. So we have, oops. This fella here is 2,445.369. And this fella here, oops, comma, 519.779, which is that fella. Okay, now that's us got half the battle done. What else have we got to do? We have got gravity, which is this thing coming down the way. I'll call it G, and that's what 0, negative 2,500. And what else do I need? Oh, I got the distance 400. So from here to here, assuming that's 400. Something else missing. What's missing? What have I missed? 400 feet, got it. Incline, got it. Weighted car, done it. Force field, done it. Gravity, gotcha. Work done by the car in overcoming gravity. Ah, does that matter? Why should it matter for gravity? I am confused, which is pretty much me at the best of times. This is not the distance moved. I started here and I finished here. So my distance fella is this fella. Oh, I gotcha. If you tell me that's 400 feet, and you also tell me that this guy here is 12 degrees, then shouldn't I be able to figure out what this vector is by just simply doing another one of these? So the x component is going to be 400 times the cosine of 12 degrees. Y is 400 times the sine of 12 degrees. And that's going to get me my distance vector. And I'm just going to write these guys down. As calculations, because I'm running short of time. What we've got, that's good. So I'm not worried about him right now, but I am going to calculate those two guys. So I'm going to take 2445.369, 519.779, and doing a dot product with 400 cosine of 12 and 400 sine of 12. And multiply, add them all up, and you're going to take their answer to the nearest 1,000. So the work done ends up being that. So if I do 2,000 of this times that guy, and 519 times that guy, and I add them all up, I should get the work done, 208,000. Not 100% comfortable with that, but I'm 90% comfortable. Plus I had to rush it. We got one last guy to do then. With the exception of 22, I'm pretty happy with the other ones. They came out relatively smoothly. But the last thing that I want to get done, which is kind of the rushing part, is that I want to do the algebra of dot products. That's, if we get that, that means I've finished today, which is gonna go. The only other things that are left in this homework are at the end, where there's a bunch of videos that you watch and then you answer the questions. So the algebra ones are, I'm looking for them. Coming up there, up there, keep going. Here we go. Question 13 is an example of that. Question 14 is an algebra, and 15. So imagine I give you a vector u, 1, 3, and a vector v, 2, -1, and a vector w, 5, -2. Suppose you get 3 vectors. If you were being asked to calculate that guy, then you would take the vector u, which is 1, 3, dot product with what you'd get if you added these. So adding these, you get 7. Adding these, you get -3. So the answer would be 1 times 7 plus 3 times -3. So that's 7, take away 9. I get the answer -2. This dot product is made up of a view and 2 guys added. It's also equal to this. Can you see why that is the same answer as this? In other words, I could find u dot v and u dot w separately and add them up. So let's just try that out. This guy here is 1 times 2 plus 3 times -1. And this guy times this guy is 1 times 5 plus 3 times -2. And this is 2 take away 3, which is -1. And this is 5 take away 6, which is -1. And lo and behold, you see the equal. So if you're wondering why these are called dot products, don't they behave very much like multiplication in the usual world, right? U times V plus W. Wouldn't this be the distributive law? Agree? Wouldn't that be like the distributive law? Then what do you think this calculation would look like if we did the algebra, right? The algebra vectors, U plus V dot U minus V. Well, you can do a FOIL. And you get U dot U take away U dot V plus V dot U minus V dot V. Isn't that just like foiling? Now, some of these guys, in particular these two, are actually the same as each other. Do you know if you do U dot V or you switch places and do V dot U, would you agree these answers are the same number? If that was 10, this would be 10. So what happens is that these two cancel out and you get the answer U dot U. So if I wanted to do this calculation, couldn't I just do this guy with himself? So U dot U would be this fella, which is 1 plus 9, which is 10. Take away this guy with himself. And this would be 4 add 1, which is 5. So take away 5, and the answer you'd get is 5. So you can simplify your workload, sometimes at least, by figuring out what the algebra of it would look like, tidy up the algebra if you're lucky, and just get 2 simpler answers, and you're finished. Any questions so far? We're almost at the end here. Okay, last guy. Suppose I tell you that 2 vectors U and V are perpendicular. And I wanted to find what those 2 guys are. U plus V dot U plus V. Then it would be U dot U plus U dot V plus V dot U plus V dot V. And not only did I want to find out what that answer is, I wanted it to be in its simplest form. What do those 2 guys equal?
Is that just 2U dot V?
Well, that's true, but what is U dot V if U and V are perpendicular? Right angles, if you prefer. What's the dot product of 2 vectors that are right angles to each other?
Wasn't that 0?
It is. So what you get is just U dot U plus V dot V. Interesting. Now, if I asked you to find the magnitude of this vector, wouldn't it be that guy squared plus that guy squared? Great. Now, if you take u dot u, you would go this vector dot product with itself. And you would get u1 squared plus u2 squared. U dot u is very often called that guy. So far, so good. Suppose I tell you that u and v are also unit vectors. If you are a unit vector, isn't your magnitude 1? So won't this guy basically be 1 squared, which is 1, which means this guy is 1 plus 1, and the answer is 2. So if I tell you that I have two vectors that are unit vectors, and that those two vectors are perpendicular to each other, then the calculation u plus v dot u plus v will always be the number 2, even although I've not told you any specific values for u and v. Every single one of them, where they are unit vectors and are perpendicular, then this dot with that dot will always be 2. It's kind of interesting that property exists. And put your name down, and we are finished for today. I'll hang about for homework questions or any other questions for that matter. I'll see you tomorrow, where we can actually get started on revising for the final.
Would you mind drawing or trying to explain what dot products are doing? Like, what are we solving for when we're doing a dot product?
What you're doing with a dot product, if I went and said to you, calculate that, let me put it onto your screen. Let's get, there we go. Right. If I said to you, let's calculate that, it's much better if you look at it with numbers. So let's suppose u is 1, 3, and let's suppose v is 5, -2. On one very superficial level, a dot product is just a formula that says you multiply the x's together. So you go 1 times 5, and you add it to the two y guys, and you get the answer 5. In this case, take away 6, you get the answer -1. So you're basically just, in a kind of way, aren't you multiplying two vectors together to get a number? Right.
Yeah.
So that is what a dot product is. Now, if you say, can you show me visually what it is? It doesn't really have a visual connotation. It doesn't really have, oh, well, if you think of this as u and you think of that as v, then the dot product is some kind of, I don't know, some kind of number that's connected directly to those two. It doesn't really work that way, but it does work in the sense that if you wanted to find the angle between two vectors, it's the dot product over their magnitude. So that, with the magnitudes of those vectors, gives you a way to find the angle theta. So the dot product is a calculation that allows us to find the angle between two vectors when you tie it together with these two fellas down here.
Okay, so it's kind of like a step that helps us learn other more important things.
Yeah. Now, if you restrict your world to unit vectors, so imagine u and v are 1 unit long, right? I'll try and make them look like the same length, right? Now, if they're 1 unit long, doesn't this formula just become the cosine of u dot v? Agreed? Because 1 and 1, it gives you 1. So if you think about that, isn't the dot product, when you're talking about in general the dot product, isn't it telling you what the cosine of the angle in between is?
Okay.
If I rewrite this even more weird, isn't the inverse cosine of the dot product the angle between two vectors?
Yes, I guess.
Right? That only is true if the u and v are unit vectors. But if you're trying to get your head around what a dot product is doing, it's telling you as a number how far apart the two vectors are. A big dot product, right? If you're talking about a big negative number, they're that far apart, right? If you're talking about a little small positive number, they're only that far apart. Does that help? A dot product is kind of telling you how far apart two vectors are.
Yes. Will unit vectors be on the test? Because they weren't on the last test we took, but we've talked about them. So I guess, are they going to be on the final?
If I've talked about them and you've done them in homework, they're on the final, and they are in homeworks. We have done unit vectors in homework.
Oh, really? I haven't found any unit vectors.
Have we not?
Homework, no.
Ah. Interesting.
Maybe.
And maybe, well, color me purple. I would have bet money that it was mentioned somewhere in one of the questions. But if it's not, then I won't give you it. Because that's only fair.
Thank you. See you tomorrow. Bye.
Okay,
So
bye-bye.
I had a question about the quiz.
Sure.
So one of the questions I don't think I knew how to do it fully.
Okay.
So if we could
Well, let me go
through
looking
it.
for that one. Okay.
I
So,
can just screen
Aaron,
share if you want me to.
even quicker. That sounds like a plan. You now have, no, you don't. I'll have to do it again because I hit the wrong button. Now you have permission. Let's see your thing.
Right, can you see that?
Yeah, I can see it now. Oh, the boat one. Yeah.
Yeah.
Okay. Now, let's start.
So one thing I
Right.
think I messed up on,
Uh-huh.
I'm not sure if that changed, it would have changed what I got, but you were talking about how with planes and whatnot, where they always have the direction of north as their.
Yeah, but this one is actually in the direction that you want it to be. It's
Okay.
in the direction of 60 degrees.
Gotcha.
So,
okay.
Just going into this one, and I want to see what the right answer is based on what you have got. Okay, so let's see here, F, A, B, C, D, E, F. Right, click on that. Question 10. Come on. There we go. Question 10. Right. Okay. Okay. You got things back to front and upside down. I wonder if you did, the right answer for the first one is 12,0. So it sounds like the y and the x component kind of switch places.
Yeah, I think that's because I was doing it basically how you do the plain ones, where you put north as your.
Oh, yeah. Yeah, even if you do, and if they told you the north was 30 degrees, you'd still use 60 degrees in the x and y component.
Oh, okay.
Right. So what I'm getting at there is, if I just return. Right. Okay, here we go. So we got the question, and it looks something like this. And this angle here is 60 degrees, right? And we're told that the speed, which is what, 12 miles per hour, is that right? A straight river flows east. Oh, the river is flowing east.
Yeah.
Right, so the river is flowing east at 12 miles per hour. So that makes the river a 12,0 guy. Agreed?
Okay.
All right. If you're talking about components, x and y component, x is how many in the x direction, and right, y component now. So 12 east would be that. Okay. Now, if you look at the other guy, you've got your 60, and the answer that you're looking at the x component should have been the magnitude, which is 22, I believe, times the cosine of 60,
Yeah.
and the y component is going to be 22 times the sine of
Sine
60.
is- Yeah.
And if you do that, guy, you should have got 11 root 3. And if you did this guy, you should have got 11. But you kind of switched them around and turned that into a decimal as well.
Well, so I got 11 for the y, and for the x, I got 19.05.
Right, so you should have basically went and said 19 point, no, we got that the right way around. No, the correct answer, I'm trying to look at your answer and it's distracting me because that's the right way around. So you should have got 11 and 19.05.
Okay.
And what you got was 19.05, 11.
So I must, yeah, I think that's what I did wrong. is
I think you must have been using
the
30 degrees all the
yeah.
time, right? So that's why everything went left and right. If you went the other way, you'd be fine. Now, when they ask you about the true velocity of the motorboat, right? So what you're looking at here is the combination of the river plus the, right, I believe that's the right way around. Okay, so what you're looking at, a 23, 19.05. Now that's the resultant force. So that's that guy, which is question C. And they use the word velocity. So when they use the word velocity, that means vector. And then they ask you for the true speed. And think of the word true speed as the magnitude of this vector. So if you find the magnitude of this vector, which is 23 squared plus 19.05 squared, you would have got the answer 29.9 according to them.
29.9.
That's what it says here. Now, they then, so if you imagine you've got your boat going this way and the current going that way, but your answer is somewhere kind of between them, right? That's your boat, the real direction. You would then find this angle. Okay, and this angle here would be 39.6 degrees. And it's at that point that they bring in the north thing just to throw you.
Yeah.
And so the number that you end up using would have been 50.4. So the only time the north thing kicked in was on the last piece of the puzzle when it asked you for the direction of the boat in terms of, well, they don't even say in terms of, but you can tell because they say N degrees east. So you know it was to do with that fella.